Hi, I'm Sean, and I'm one of the creators of Koji. Koji is a platform that makes it trivially easy for anyone to create apps and games, even if they don't know how to code. Everything happens from inside the browser, and the apps and games created are web-based, which means that they're instantly available to play on every device with an internet connection, in every form factor, on every operating system. You don't need to install anything on the App Store. You can play them on any phone, and they even embed natively on Reddit, Snap, and Instagram. And if you look through the site now, what you'll see are mostly these fun, hyper-casual games. But each of these games is actually a full-stack web app that's been built and deployed using modern standards and is ready to scale to millions of users. These games are easy for novices and non-technical people to customize without ever seeing a line of code. But if you're a developer, or even if you're just getting started programming, you can take these things and remix them, and you get full access to all of the code, which means that you can extend them in all kinds of amazing ways. Up until now, I've been pretty much the only developer building out the platform side of this thing, and I'm super proud of it and how it's turned out so far and what our early creators are making. So I'd like to take some time to share a more technical, behind-the-scenes look at what's going on here. Because, if you just showed up and poked around a bit, you might think, oh, this is a cool tool for customizing, fun games. But there's actually a ton of tech that drives this thing to make it feel as easy and approachable as it does, while still also facilitating our broader, more long-term vision for what this platform is. So we start with a simple premise, which is that every app on Koji is remixable. In the background, we're running a Git server similar to github.com, and the code for each Koji app is stored as a Git repository. So when you remix a project, what you're doing is you're forking the Git repo and cloning the source code onto your own account, so you have a fresh cut of the project to work from. And then alongside the code, the development environment for each project is also packaged up as a Docker image. And when you remix a project, you also get a fresh copy of that image. So when you see this loading app screen, what's happening is that we're pulling a machine from a pool and booting that dev image onto it. We're wiring up your Git remotes, and then we're sideloading the backend of the Koji editor, which is this thing that we call Remy, which is the name of the rat in Ratatouille. We're sideloading Remy alongside your code into the container. And then Remy starts up a WebSocket server that punches out of the container, and your browser connects to that. So your browser is actually connecting directly inside of the remote container where your code is running. What this means is that you have a full Linux development environment to work with. So you can run backend servers, you can run development servers as you're working on your front end, you can install packages that might have native bindings, all kinds of good things that you wouldn't get with a simple browser abstraction. And then you obviously get a full shell to work with, a full bash shell, including fully featured Gits. So that's pretty cool too. You can think of the web editor as simply rendering the state of the remote container of this Remy instance. So things like open files and cursor selections and these terminals and all of that are managed on Remy, and the client-side mutations to those things are processed on Remy. So essentially we're kind of live streaming this functional editor down to your browser, which has a few really interesting implications. One is that rendering this editor doesn't require installing anything locally or have any device requirements. So you can do it from any device with a browser. And this includes tablets running iOS and Android, and the kinds of shared computers that you might find in like a university library or an internet cafe. And you normally wouldn't be able to develop on those kinds of machines because you have to install a bunch of stuff to even get started. But here all of that stuff is installed on your server in the cloud, and you're simply connecting to it from your browser. It also means that the editor easily facilitates paired collaborative work. So because there's only sort of one true editor that exists on this remote machine, and your browser is simply connecting to that editor when you load it up, you can just grant other people access to the same editor, and they see the exact same thing you see. They see the same open files, the terminals, the live previews, etc. And then actually mutating file contents in these multi-user sessions is done via functional operations. So you can even edit the same file Google Docs style and see each other's cursors and selections. Plus, this is awesome for pair programming, especially in educational contexts. Letting a more experienced developer jump in and parachute into a session and help people fix their problems in real time is super powerful. And then because all of these projects are just Git repositories, any more sort of serious or asynchronous collaboration can just be done using normal Git workflows. So what you're seeing here is the Koji editor. And I mentioned that each of these projects is a full stack JavaScript app. So you can see at the bottom, I've got two terminal tabs. I've got my front end dev server and I've got my back end API server. These are full bash shells. I can, spawn new ones if I want. But the configuration files for the project predefine the ones that are necessary to get the live preview up and running. And then you can see this live preview on the right over here, where I can play it, right from inside the editor. I can also change its size to test responsiveness, and I can pop it out over here to see console logs. So if I change something here, you can see it reloading over here, which is cool. And then because the editor is hosted remotely, so is this live preview. And because we take care of HTTPS termination when we proxy connections into the editor, the local host that's running this thing is now remotely accessible and also secure by default. So if you've ever had to use something like ngrok or Charles Proxy before when you're trying to do remote debugging, or you've had to make sure your teammates were on the same Wi-Fi as you in order to get a local IP working, those problems don't exist in Koji. I can basically take this live preview and open it in a new tab and get this Koji staging link, which is around for as long as this editor is open, and then it dies after 15 minutes of inactivity. And I can send this link to anyone in the world and they can watch me develop in real time. We can even collaborate on things like design or colors because this is a hot reloading link. So it's the ultimate tool for pixel tweaking basically. So I can also scan this QR code with my camera and get a live preview on my phone with 0 additional configuration required. And then to make it even cooler, the console logs from my phone are being streamed back into the editor, so I can get console output from the phone, which, without this, it's a pain to really debug web apps on especially iPhones, because unless you own a Mac and you physically connect your phone to your computer and configure remote debugging in Safari, you have no idea what's actually going on this thing. Also, this is a smart feature phone running something called KaiOS, which is the second most popular operating system on India. And this phone only runs web apps. But if you want to develop on this phone, you have to install an old version of Firefox and you have to use ADB, and it's, kind of an involved process to get a remote development environment running on this thing. Or I can use the QR scanner on this phone and scan the code and I can get my logs. You don't need to connect anything or configure any device permissions. You're good to go. You've got this app running on your phone with live reloading and logging. So the third tab on this live preview is a route previewer for testing backend routes, which is similar to Postman or curl. And you can build your request in here. And then once you've built it, you can easily get the code required to add it to your front end. Okay, so let's talk a little bit about VCCs, Visual Customization Controls. If you look at a lot of the no-code tools that are out there right now, and if you look historically at various attempts to build no-code or low-code programming tools, they all tend to run up against the same sorts of fundamental problems. One is that you can either take the approach of let's model every possible thing in a visual interface and give it to people, in which case you've basically created another programming language that is way more verbose than just typing and requires a ton of clicking and increases exponentially in complexity. Or the alternative is you can try and define a narrow set of abstractions and pare things down into these more intuitive interfaces that non-programmers aren't afraid of, which is cool when the user's constraints, when the constraints of their project fit within that narrow set of abstractions. But the problem is that once their requirements go beyond the scope of those abstractions, they're left in the dust. Basically, every project beyond the most simple ones are going to reach some point of complexity or nuance where the user's only option is to abandon the no-code tool and just rebuild the entire thing starting from scratch in code. And, I feel sort of qualified to make some of these claims because the first product we built, Metaverse Studio, fits a bit into both of those boxes. It's a drag and drop augmented reality builder with logic controls, and it's got some awesome use cases, especially in education. But the types of things that you can create with it are fundamentally constrained by the fact that it is this visual and flow-based editor. So with Koji, we set out to build something that gets you the best of both worlds, which is these easy no-code customizations that are accessible to non-technical people, but backed by all of the power of code for more technical people to go in and extend them and to grow. So you never run up against any of these artificial constraints where you need to drop the thing and just go, because all of these projects are just code. So these controls are defined by JSON files that developers create inside their projects in order to abstract things that they think non-technical people might want to customize when they remix it. So these are things like colors, strings, game mechanics, API keys, stuff like that. And then alongside this JSON file, the developer provides an object that associates each of those fields with some additional metadata and then also a type. And right now the types include things like text and numbers and toggles, images, sounds, secret keys, things like that. But eventually they could grow to include more complex controls. And the interesting thing about this pattern is that it means that the visual abstractions are built with intention from the developer who is writing the code. So instead of us trying to analyze some piece of code and render every possible option as a visual control and then ending up with like 1,000 different controls for margin and padding and color, the developer of the app has the opportunity to try to highlight and surface what matters and what will actually be valuable to people when they remix it. And the cool part about this is that if they miss something, it's trivially easy for someone to go in and add a new VCC to control it. Or if you're more technical, you might be better off just going into the code and modifying the thing directly. Because I think like once you get past that scary, oh my God, feeling of seeing code for the first time, it's way easier to understand a loop when it's spelled out than it is to like figure out some puzzle like visual abstraction. And I think that's true for a lot of concepts in code. It's just easier to manipulate them in code than it is with some kind of visual interface. So by having both of them, we've got this ramp that lets users grow from one to the other or between the two kind of at their own pace wherever they're comfortable. Like I learned how to code by clicking view source on websites and copy pasting stuff and trying to see what happened. And with the modern web, you can't really do that anymore because everything is minified and bundled. And it's cool to kind of have this thing where we're bringing back that ability to, peek behind the veil and poke around. So that's another exciting piece of this. Some other cool things about VCCs, the content that's uploaded using these controls is hosted on our CDN. So it's accelerated and secure by default and scoped to your project. So you don't have to worry about mixed security content warnings or anything like that. Images that are uploaded using the image VCC are processed through ImageX. So you get access to all kinds of awesome parameters like sizing and cropping and face detection and blurring and anything like that, which is really cool. So this is another VCC type for storing secret keys, which uses a shared key store that is unique to your account and scoped to individual projects. Most of the apps that you'll remix don't use this right now, but if you're remixing something more complex that uses, say, like Firebase or some kind of third-party API, the VCC can ask for your API tokens. And if you've already used an API with a similar key domain in the past, you can simply authorize the same key for this new project. And then the keys are made available to your app at runtime as environment variables. So you don't have to worry about leaking secrets when your project is remixed or anything like that. And then behind the scenes, this is all secured with an AWS product called KMS. So that's the editor piece of things. Now let's talk a little bit about deploying. Deploying things and maintaining them in production is difficult, like crazy difficult. DevOps is an entire profession. And like, don't get me wrong, it's amazing. And the tools that are available to you are amazing. And I'm definitely not trying to dismiss their necessity. But if I want to make something small or medium-sized even, and just kind of get it out there simply, easily, and securely, and share it with people, the tools that are available to me from the ops side of things, they're either designed for like these big teams and these giant projects or like tiny little fun sandboxes, playgrounds, things like that. Like the small to mid-sized deployment use case is dramatically underserved in this modern web ecosystem. So another place we've invested a lot of time with Koji is in making it easy to publish with one click. And there are two major pieces that facilitate this, our CI and our CDN. And the first step in deploying is compiling and bundling. So you get to use this nice bloated Webpack development server and development frameworks with source maps as you're building your project. But when it comes time to actually serve it to people, you want this fast, minified, transpiled bundle that works across all these different browsers and different device targets. So those instructions are provided in a config file, which is pretty similar to other CI services. And you tell us about the services in your project. In this case, we've got a front end and a back end, and you specify the build steps. And then when you hit publish, Koji commits your changes and pushes them to the remote repository, which fires off a Git hook to the CI service. And then the CI service clones master, puts together the build plan, and runs the steps for each service inside of a container to get a distribution bundle. Now, services can deploy to one of two targets. They can either deploy a static bundle, so just HTML, CSS, JavaScript, or they can deploy as a dynamic bundle that runs a container on Google Cloud Run, which is this awesome product out of Google that's basically like AWS Lambda, but for entire servers. So you, as an app developer, don't need to do anything special other than make sure that your server picks up its port from the environment. And then we take care of building the production bundle, creating the production container, and deploying and managing it for you. You can see deploy logs in this versions tab over here. So you can kind of debug things if you need to. And because all of this is Git-based, you can actually develop outside of the editor and then deploy by pushing from your command line, but we haven't really built workflows to support that use case just yet. Okay, so the second piece of publishing is once your project is deployed, how do your users actually access it? And if you were doing this without Koji, that would likely mean some combination of configuring DNS, CDNs, load balancers, HTTPS termination, Nginx configs, URL rewriting, process monitoring, all kinds of stuff. But Koji takes care of all of that for you out of the box. So we take care of CDN via Fastly, which is the same CDN that powers GitHub and Reddit. Each service in your deployed project gets an auto-generated domain name, and we proxy that domain name to serve your content. You can also give each service a custom domain name on one of the subdomains that we own, or you can buy your own domain name and configure its DNS to point to Koji, and we'll serve your project on that domain. We take care of HTTPS automatically, including for custom domains. So this means we procure, serve, and renew certificates for all of your domains. And we also terminate HTTPS at our edge. So your apps don't need to have like separate listeners for HTTPS or managed certificates or anything like that. They are fast and secure by default. A few other goodies in here. We've got the Koji Database, which is a simple key value store that lets you easily capture data from your backends. If you need something hyper performant or you need complex joins or things like that, you can always just use the secret key store VCC to connect to some third-party database. But if all you need is a simple way to collect data, then this works great. You can even define custom views inside the project in JSON to actually map the data objects into nice lists that can then be downloaded as CSVs. A lot of people are using this right now to add leaderboards or other data collection into their apps and games. Plugins are also super cool. They're an easy way to inject additional code into apps that's injected at request time into the compiled bundle. So you can think of them as kind of a way to inject like add units into apps. They don't actually interface with the project's code. They sit at a level above it, which lets you do things like add in these banners that come down from the top, or like pre-roll graphics, or like secret password walls that people need to type in the secret password before they can get to your app. They also let you do like code level things like add and configure open graph tags so social crawlers can render your app nicely in feeds. So we haven't opened up plugins to third-party developers yet, but let me show you what this thing looks like from the backend, since that is on our list. These are our admin tools, by the way, so excuse the mess. But basically plugins are, let's go to this one. Plugins are a set of injections. And each injection looks for a path that matches some pattern and then attempts to find an injection site as it's streaming the file to the client. And then when it finds the site, it adds in the specified code. And that code can also have variables that are configured using the same VCC engine as the rest of the editor. And an interesting kind of consequence of doing it like this is that the paths that it's looking for don't necessarily need to be patterns. They can be explicit paths. So they can serve things like the PWA manifest, or like KaiOS, the TinyPhone has an add SDK that requires a one-liner in the app's body and then an additional JavaScript file. So we can add in the one-liner using an injection in any HTML page, and then we can add in the ads SDK to serve it from this synthetic path. So analytics in the editor here are based on access logs from the CDN. If you want more precise analytics, you can just enable the Google Analytics plugin. But this shows, general traffic and the number of unique visitors and referrers, which is really cool. Scheduled jobs are also really cool. They basically let you define cron jobs for your deployed app. So, for example, if you created a backend service that had some endpoint to run a job, like to post to Twitter or to send an email or something like that, you can use the scheduled jobs interface to build an HTTP request that'll run at the scheduled time to hit that endpoint and run the job. And these jobs are defined as JSON that gets included in the project, so they're ready to go when an app is remixed without requiring any additional configuration from the user who's doing the remixing. So you can build kind of chatbots or Twitter bots or things like that with this. It's super cool. Not a lot of things are using this yet, but I think it's going to be something that's super powerful in the future. So by default, apps get published to withkoji.com, which is our browsing and discovery interface. If you don't want that, you can toggle it off and just point people to your app's fully qualified domain name, and they never need to know that it was made with Koji or what Koji even is. But if you do choose to publish here, you get the advantage of people discovering your app or game as they're just browsing around. And it also makes it easy for other people to come along and remix your project and make something new and be creative with it, which is really cool. And then in addition to that, the withkoji.com domain is whitelisted by a lot of social networks and messaging providers. So if you share this link, it gets embedded natively inside of Reddit, inside of Snap, inside of Instagram. So people don't need to, open a new tab or open a browser. They can play your game right as they're scrolling through their content, which is really cool. They don't need to leave and go to a separate site or anything like that. I've probably forgotten a bunch of stuff, but hopefully this gives you enough of an overview into some of the pieces of the software development lifecycle that we touch and some of the places that we play and some of the places that we're going. I am, crazy excited about this thing and like this ability to go from the world we've been living in where like if I want to create, even the most simple of games, I need to buy an iPhone and a Mac and build it in Swift. And then I also need to go and I need to learn Java or Kotlin and build it on Android. And then I probably am still going to need to learn like web and DevOps if it's going to have any sort of backend. Like to go from that into this world where like I can remix anything, I can change things around, I can press publish, and I can have it be instantly available on every phone, on every desktop, on every tablet, smart fridge, Tesla, Facebook portal, TV, have it like inside of Reddit posts, inside of Instagram stories, like everything, with no friction of trying to convince your end user to install some app on the App Store and take up space on their home screen, or like have to, even deal with getting approved to be on the App Store and all the stuff that's involved in that. Like that's crazy powerful and exciting to me. Thanks for sticking around and watching this whole thing. If you are curious to learn more, please message me. I'm happy to talk about this thing for hours and, show you even deeper dives into things. Yeah, cool. Okay. Ciao.